Alright, so let's look at some of these shear and moment diagram problems. These were in the PowerPoint notes. And I thought it would be good just to go through these kind of quickly to kind of remind you of the critical or the important parts and how to apply them. Now, in a lot of these first problems that I'm going to do, I'm not going to take the time to do the reactions. I'm going to just tell you what the reactions are. In most cases, you'll probably think that that's a reasonable idea. I don't think it'll take you too long to figure out that with a cantilever beam and a simple load that the shear is also P and that the reaction moment is PL. Okay? So let's start with the shear diagram. Starting from the left and working to the right, I look at this force. Is this a positive shear or a negative shear? Positive. So I should start at P. Now, what kind of shear do I have out here at the free end?
Positive.
Yeah, why do you know that? What if I were to take a little bitty chunk of the beam? Kind of a differential chunk. And I know on the right edge is the load P, and on the left edge this is positive shear. Right? So what would that shear be? P. Right? And it would be positive. So you're right. I should come over here and hit positive P. Now let's see if that works. Remember, our basic relationship is that the change in shear is the area under the load diagram. What's the area under our load diagram? 0. So if I start at P, there'll be no change, so I should get the P. That seems to match. Also, that the slope of the shear diagram is equal to the loading. What's the loading? 0. And 0 slope is a horizontal line, so I should just connect the dots. So there's my shear diagram. Let's start with moment now. What kind of bending moment is this at the reaction? Positive or negative bending moment? It's a negative bending moment. What's the bending moment at the free end? 0. So my relationships say the change in moment is the integral under the shear diagram. What is the integral under the shear diagram? Or the area under the shear diagram? It's a rectangle. It's just base L times height P, and it's positive, right? So positive PL. So if I start at negative PL and I add PL to it, I get excellent. And now the slope of that curve is equal to the shear. So let's go look at the shear. What's the value of the shear here? P. Positive or negative?
Positive.
What's the value of it here?
P.
Positive or negative?
Positive.
What's the value of it here?
P.
Do you see a pattern? It's constant, positive, slope. What kind of curve has a constant positive slope? In fact, if I looked at that, for every 1 I would go up P. So there's my moment diagram. You will have a big smile on your face if you have that on the exam. I can't guarantee that kind of smile. All right, let's look at the second one. What's different? Let's look at the reactions first. Is there a shear here? If you were to sum forces in the y direction to find this shear value, what would you find? The shear is 0. What about the moment? I think you'll see the reaction moment is just equal and opposite. So what's my shear diagram look like? Well, if I start at 0 shear, and the change in shear is the area in the load curve, and the load curve is 0, so I should hit 0. And the shape of my curve in between is given by this expression. It says the slope is equal to the load. The load is always 0. So you have no shear. Shearless. Now let's do the moment. What kind of moment is this? What kind of bending moment is this? Positive or negative? I heard both answers. Is it positive? Let's all vote for it. Is this positive bending moment? Say aye.
Aye.
Let the microphone record. Any nays? Good. I like that. It is positive. By the way, what kind of bending moment is this over here?
Positive.
Bending moment.
Positive.
Positive. So now, the change in moments to area of the shear diagram. What is the area of the shear diagram? 0. So if you start at M naught and you add nothing to it, you get... Excellent. So what is the slope of this curve? Why? Because the slope is equal to the shear, and the shear has a value of 0, and this is a 0 slope curve. So there is my moment diagram. Any questions about these? All right, I'm going to stop.